Now I believe everything is working according to plan. Now we just have to wait for the other members and for Marcelo, and we can start.
Sounds good.
Hello.
Morning. Good morning. Hi, Toshi. Very nice to see you.
Nice to see you too, Marcelo. Thanks again for the invitation. It's very kind of you.
Thank you very, very much for being here. It's very important for us to hear your opinion, your very qualified opinion. It's very important for us.
That's already very flattering, Marcelo. And, very honored to be here, of course. And,
How are you doing?
surviving. It's, I think the pandemic has been also affecting me and my family to some extent. I also got COVID like a month ago, but it wasn't too bad in the end. And now we are all kind of relaxed a little bit, because we were always kind of afraid, trying not to get it and so on and so forth. But now psychologically, okay, we know how it is like. It's not great to get it, but at the same time, it's not the worst. We're at least vaccinated and so on and so forth and stuff. But yeah, I mean, life, the world is so different now. I mean, on top of this crisis in Ukraine is just, I mean, I all of these things have been just making my mind so upset. And then on top of that, always there are some sad happenings here and there too, So I feel like I'm getting old, Marcelo,
Very young. Come on. But it's true. Time is run over all of you, all of us.
No, because for example, yesterday I was talking to Daniel Skurt, one of my friends, of course.
Yes.
And upon talking about some things, I realized I was for the first time I met you in person in Melbourne at the WCP4.
Wow.
And that is already like 14 years ago, and I just can't believe that. It's like 14 years. I mean, unbelievable. It's just time flies, literally.
Exactly. Yes. We realize that we are getting older when we speak about decades. Yes, 10, 20 years ago, you remember things that you have done 20 years ago. Then at that time, you realize that, well, I'm getting old. It's terrible. But it's not so bad.
No, the life is still worth living, and it's still very beautiful in a number of different ways, So I never think this is the argument against these things, but still there's too many crazy things going on, and I just hope that the world won't go too crazy any further. It's already crazy enough. We really hope that there's going to be some more reasonable things.
I'm a little bit skeptical about that. Things are never too crazy enough. There's always, it can always get a little bit crazier for us. It will happen eventually.
I mean, look, scientifically, going a bit more crazier is probably always a good way. But I think in the real life, I mean, there's a limit, I mean, science can be a bit more free, right? And more creative, right? But I think that's an interesting kind of difference, I think mathematics are a lot more free compared to the real world, and then philosophy is probably a bit more constrained than mathematics is, right? And then it's not easy to compare, of course, but
exactly. But you are right in that point. Philosophy has certain limits or bounds that in mathematics, for instance, computer science, you don't have, because it is free science. It's inventions of us.
Yes. But of course, in the age of this computer science flourishing so much and mathematical theorizing playing such an important role, it does start to become a very non-trivial question if this mathematical freedom is really okay to let things used to be like, because, but
Hercules.
Hercules.
Hercules is coming. Hercules Feitosa.
Professor Marcelo, Darlan is also here. You are receiving the little...
Hi, Hercules. Welcome.
Hello. Thank you for coming.
Very
Thank
nice.
you very much. Darlan as well. Darlan has just arrived.
Darlan.
Hello.
Welcome.
Thank you for work for us.
Usually, Hitoshi, Hercules, and Darlan. All good friends. Thank you very much for coming.
Oh, thanks so much
very much so. We are very thankful. Marcelo, I was going to ask, you are receiving the little pop-ups asking if people can come in?
Yes.
Yes. Okay.
But I need your authorization for entering to the room. Anna is coming.
Anna is here as well.
Very, very nice. Hello, Anna. Welcome. Anna is here.
I guess you got no video. Hello, Anna. Professor Anna, of course. Hello.
Hi, Anna. Welcome. Thank you very much for being with us. You are without sound. Still not hearing you. Maybe little problem with the microphone. Still not. Technology is always against us, attacking us.
Okay.
Now it's turned on your microphone, Anna, right?
Now the audio is on. No, I can't seem to hear.
Yes.
I don't know if...
Maybe you can leave out and enter again, maybe. Sometimes it works. I don't know why.
Everyone can hear me? Or
Yes, yes.
yeah? Okay.
Perfect.
Hello, Walter.
Walter is here.
He is here.
Perfect, perfect. Good morning, Walter. Welcome.
Bom dia. Olá, bom dia. Good morning.
Good morning.
Guilherme. Hitoshi, Darlan, Hercules, and Anna. Nice to see you here.
Nice to see you, Walter.
It's not working still, Anna. Anna has problem with the microphone. Maybe you can try with cell phone simultaneously.
Yes, okay, I will do that.
Now I hear you.
Now it works. Why? We don't know.
Great.
Very nice, very nice. Well, we are almost at time to start because it's a formal ceremony. We need to respect the time, and we will start at 9 o'clock, a bit later, but never early. Guilherme, do you have your slide prepared?
Yes.
Okay, perfect.
They're here.
Okay, very nice. It's very nice to count with your presence, very values for us. We are very grateful for the time you have dedicated to read the thesis from Guilherme. That was not so easy task, we recognize, and some parts are a bit dense, but we hope that you have enjoyed the lecture, and we will discuss now the merits, like the scientific merits of the thesis by Guilherme. Guilherme will start with a presentation about 50 minutes, Guilherme, maybe.
15 minutes? 9:15?
No, the time of your presentation.
Yes, 50 minutes, around 50 minutes. I will try to keep within this frame. And if there are further questions, we can leave for after the presentation, or
yes,
I don't
exactly.
know, if someone thinks there is a poignant question to make, maybe there is no problem in allowing the presentation to be briefly stopped for that.
Yes, of course.
Itala is here.
Very nice.
She would be able to.
Welcome, Itala.
Hello.
Very nice to
Hello, hi.
To come with you.
I think she's mute, but I don't know if that's by option. Here.
No.
Hello.
Hello, Itala.
Hi,
Hello.
Thank you for coming.
Como vão todos? How are you? Hi, Anna.
Very nice.
Hello,
we are
nice
all
to
very
see you.
glad.
Nice to meet you. You're
Very
welcome
nice.
to our meeting, to our Brazilian meeting.
Yes, it's great. Yes, Brazilian meeting. You're right. I will just a minute, please.
Hi, Toledo, Guilherme. How are
Hello,
you?
Itala. Thank you. Thank you for being able to come. We are very happy about everyone. Okay. We are very thankful.
Hércules, tudo bom? Darlan.
Very nice. Well, then let's start because it's 9 o'clock. Perfect. Then Guilherme, can you start the recording of the session?
No, sorry. We are already live streaming. So a few people with the link. Okay, everyone that seen the announce of my defense is able to see us through the link, through the live streaming link, and YouTube is already recording this conversation since 10, 15 minutes before 9 o'clock. So all of this is already recorded. Sorry, people, I should have warned before, but
yes, on the other hand, it's a formal requirement of the Unicamp.
Yes.
The university requires to have recorded the session because it's a document, let's say. Perfect. Well,
I think they don't even request that we record it, but we must live stream. That's
yes, you're right.
Necessary.
You're right.
Yes.
Perfect. Okay, well, being 1 minute past 9, we will start formally our session of the oral defense of the PhD thesis by Guilherme Vicentin Toledo from the Department of Philosophy of the State University of Campinas. The name of the thesis is multi-algebras and no-deterministic semantics applied to paraconsistent logics, multi-álgebras y semánticas no determinísticas aplicadas a lógicas paraconsistentes, with the aim of obtaining the title of PhD in philosophy. Okay, I am very grateful to the members of the jury which are present here. From the University of Campinas, Walter Carnielli, as and Italo Ottaviano, from the University of Bahia, Darlan Concepcion Pinto, from the Ruhr University in Germany, Hitoshi Omori, from the University of Haifa, Israel, Anna Zamansky, and Hercules Feitosa also from the University of San Paulo State. Thank you very much for everybody for coming here today. Sorry. And we will start the session with, as usual, a presentation, oral presentation by the candidate, Guilherme. He will present the main results developed in her thesis. And after this presentation, it will take about 50 minutes. We will proceed to argue to the candidate. Okay, each member has about 30 minutes for questions at maximum, and the candidate has the same time for answer. Okay, then Guilherme, please start with your presentation.
Thank you, Marcelo. I would like again to thank everyone for being able to come. It's we are very thankful. We are very thankful for the comments to come as well. We are sure that many new ideas may appear in this conversation as well. Yes, I will try to keep the presentation within 50 minutes. I think most questions can be asked later, but if there is any question that people feel it should be asked during the presentation, I think a short pause would be not a problem. I have a little digital board, so further explanations can be made in a whiteboard. I think that's very useful. So again, we are already live streaming, and then I will start the presentation. If there's no question before the presentation itself, I will start. So I hope everyone is
Yes, yes.
in the presentation here.
It's okay.
Okay. I hope everyone is hearing me as well. So, as Marcelo said, it's my thesis is about multi-algebras and non-deterministic semantics applied to per-consistent logics and other systems as well. So, I tried to divide the presentation in sections with the same names as the chapters of the thesis, so there's nothing new here. Now, what we believe are the main contributions of the thesis? Well, in multi-algebras, we try to generalize absolutely free algebras to something that should correspond to absolutely free multi-algebras. We believe to have achieved the correct generalization, and that's very interesting. Now, we also offer deterministic semantics that carry an order that can replace certain non-deterministic semantics. Why is that? Well, we have met some people that are philosophically against non-determinism in their semantics. So we offer this alternative, not because we believe non-deterministic semantics are not great, but because there are people who would prefer a more classical environment to work within. Now, in logic, our main developments are in logic, at least we believe that. We have developed Rn matrices, that is, restricted non-deterministic matrices, that combine N matrices with a few extra conditions. We will explain them later. And, well, we use this semantics to characterize several systems, including the Costas logics, which are very difficult to characterize. Furthermore, thinking about logics of inconsistency, we attempted to generalize them into logics dealing with formal incompatibility instead of formal inconsistency. We characterize them, we give them semantics based on Rn matrices, and we show why we need Rn matrices to characterize them, because they are very difficult as well to work with. Now, we will start. This first chapter is it just lays the main algebraic ideas that we will use throughout the thesis. So I will skim through it. What are multi-algebras? Multi-algebras are sets called universes equipped with functions that are indexed by a signature, that is a collection of symbols. And, if sigma is a symbol of arity n, then the corresponding function is an n-ary function, but that returns a non-empty subset of the universe. We require that the set is non-empty here. Our homomorphism is a function between universe satisfying this condition. If we replace inclusion by equality, we get a full homomorphism. And if the function is furthermore bijective, then we get an isomorphism of multi-algebras. Well, if we have objects as well as morphisms between them, of course, we get a category, which we call M-alg sigma. A few notational points. The algebra of formulas in the signature sigma and variables V, we will denote like this. We use the same notation for the underlying multi-algebra as well. We believe there is no risk of confusion. And, An important point when talking about multi-algebras and algebraic structures in general is how you interpret a formula. Well, in the field of multi-algebras, there's different notions of interpreting a formula. The one we mostly will talk about is legal valuations. That is, homomorphisms from the multi-algebra formulas within the multi-algebra at hand. And the interpretation, one interpretation of alpha is then V of alpha. Well, there are other possible interpretations of notions of interpretation of a formula. One is a full multi-homomorphism. Here is it's just an algebraic idea of how different notions can lead to different results in the field of multi-algebras. So just a brief idea. We will not work with it a lot. So a full multi-homomorphism is a multifunction that does not return at the empty set, satisfying this condition. And well, for every interpretation of the variables, there's a unique full multi-homomorphism extending it. That's a very desirable property, but this does not translate in being an effective semantic for logics. So we will prefer to use legal valuations that are much simpler in a sense, but more complex in another sense, because there is no unique extension. But this will remain only a curiosity. So now, weakly free multi-algebras. Weakly free multi-algebras are our attempt at generalizing absolutely free algebras. So, well, how you define an absolutely free algebra? There's several ways of defining them. Probably the most obvious one is, well, it is an algebra that has the unique extension property to homomorphisms that happens to be exactly the algebras of formulas. That's a great coincidence that is very desirable. And we will attempt to generalize them in both fronts. So we will generalize the unique extension of to homomorphisms. We will generalize algebras of formulas, and this coincidence will remain. Both concepts will be one and the same. So how we do that? Well, take a signature sigma, a cardinal kappa greater than 0, and take the pairs of symbols in sigma and cardinals less than kappa. We will denote such a pair like this. And then we define a certain multi-algebra, MF sigma V kappa, as having universe over this strange signature we have defined here. And then multi-operations like this, okay? We are basically indexing the results by kappa. So there are a lot of formulas. They are not exactly formulas, but they are indexed formulas. And then the sub-multi-algebras of this object will be called the weakly free multi-algebras. So instead of 4 algebras of formulas, we got sub-objects of this. Then, this is one of the definitions one of the generalized definitions. So now we take between multi-algebras A and B a collection of choices between them. What is a collection of choices? A collection of choices are functions indexed by the symbols in the signature of arity n plus n tuples in the universe of A, n tuples in the universe of B, and these are functions with this form. So, then a multi-algebra is said to be choice-dependent freely generated or CDF generated when for every function and every collection of choices, there is a unique homomorphism extending both the function and the collection of choices whenever possible. This is formally defined like this. We argue a little bit more about it in the thesis. And what we get is that a multi-algebra is weakly free, meaning is an object of these multi-algebras of formulas, if and only if it satisfies this condition, is CDF generated. So both concepts coincide. That's a very strong result. A few more results about it. We'll use a few other notions in the topic of multi-algebras. So a multi-algebra, we call it disconnected when the result of operations are disjoint. The caveat is you can't take the exact same operation in both sides. The build of a multi-algebra is the union of all the results of operations in it. That is, these are all the achievable elements. The ground is the complement of the build. The ground is the set of non-achievable elements. A strong basis of a multi-algebra is a minimum generating set, not a minimal as in vector spaces, but a minimum generating set. Here we define generating sets for multi-algebras, but I will not speak about it. And finally, a sequence in a multi-algebra is a chain whenever a given element of the sequence can be obtained by an operation performed over the next element of the sequence. That is, a chain is a sequence of further and further less complex elements. It's a way to see that. And then a multi-algebra is chainless whenever it has no chains. And then we have that a multi-algebra is weakly free if and only if every one of these conditions is satisfied. So it is disconnected and generated by its ground. It is disconnected and has a strong basis. It is disconnected and chainless. So we have very different characterizations of being weakly free, what suggests that that is an important notion to consider. Now, a final remark about weakly free multi-algebras is that they help us to see that we can define multi-algebra, absolutely free multi-algebras, as we did for algebras. That does not work. Furthermore, with this, these are a few folkloric results we proved using weakly free multi-algebras to show one application. The forgetful functor does not have a left-half joint, and this category of multi-algebras does not have initial objects. All of this follows from a simple use of weakly free multi-algebras. Now, we go to the final point in the final chapter in the part devoted to multi-algebras that offers an alternative to non-deterministic semantics, not because we don't believe in non-deterministic semantics, but because it's nice to have an alternative. So we try to make a multi-algebra into an algebra PA by taking the power set without the empty set and performing operations as it would be expected, basically uniting them all. And well, that's not very successful because there are non-isomorphic multi-algebras NAB with isomorphic PA and PB. What is missing? What is missing is the order. So we define bottomless Boolean algebras. Well, that's a very strange bottomless Boolean algebras. How is that possible? It's just the name that seemed more appropriate to us. Basically, it is a pose set such that if you add a bottom element, then you get a Boolean algebra. So if we define complete atomic bottomless Boolean algebras as those pose sets such that if you add a bottom, you get a complete atomic Boolean algebra, then the complete atomic bottomless Boolean algebras are exactly what we wish them to be. That is, power sets without the empty set. It's just another characterization of these objects. So we don't need to speak directly of power sets. Then we define sigma-ordered algebras. They are triples such that it is an algebra. It is also a complete atomic bottomless Boolean algebra, meaning that it is a power set without the empty set. And there is a condition connecting the two of these. So you can obtain an operation by taking a supremum of operations performed on atoms. Finally, we define homomorphisms between these objects. If we look at these conditions, it's very natural. These are continuous, continuous in the sense of the order. Atoms preserving, we need to preserve atoms. We could use an opposite category and avoid this condition, but we prefer that the functions preserve atoms, and they are almost a homomorphism between these objects. Then, if we define a category of sigma-ordered algebras, we can define a functor from multi-algebras to these objects, extending the idea behind this functor we were defining, but now taking into consideration the order. We define a functor in the opposite direction that takes a sigma-ordered algebra to its multi-algebra of atoms. And then these two functors are an equivalence between the categories of multi-algebras and the category of sigma-ordered algebras. So we have a deterministic alternative to multi-algebras. And that's not to say that we shouldn't use non-deterministic semantics. We prefer them, but it's an alternative. Furthermore, by looking at this functor in the correct way, it becomes part of a monad, as the power set functor before it. So now we go to the main part of the thesis that deals with logics and non-deterministic semantics. Well, a few notions here are very basic, so I will try to go over them very briefly. What is a logic? A logic, we will understand them as a set of formulas equipped with a consequence relation. We would like a logic to be Tarskian, that is, it must satisfy a few conditions. Then, a logic is finitary. Whenever you have a proof like this, you can find a finite set of premises that also accomplishes the proof. A logic is structural when you substitute variables, then the validity of an argument stays the same. And then a set of formulas is closed whenever it contains anything it can prove. And then you get Lindemann and Mosch's theorem that we don't use here in the presentation, but that we use several times throughout the thesis. We will prefer to look at logics as Hilbert systems. That is, you have axioms, you have rules of deductions, and then gamma proves phi whenever there is a sequence that ends in phi, such that every element of the sequence is either a premise, an axiom, or it can be deduced from previous elements of the sequence using a rule of deduction, one of these rules of deduction. Just a comment, we will use mostly only modus ponens. I can remember another rule of deduction in what is to come. Now, paraconsistent logics. We talked a lot about them. What are they? Well, take an unary connective in a logic. We can call it a negation. And this negation satisfies the explosion law whenever, if you have alpha and you have not alpha, then anything follows, even if it's not related to alpha or not alpha. A logic has a paraconsistent negation if it has a negation that does not satisfy the explosion law. That's the main idea behind paraconsistent logics. That is, contradictions are not trivializing here. I'm thinking about contradictions as having a formula and its negation. So contradictions are not trivializing. That's the motto here. Now, what are a few paraconsistent logics? We like logics of formal inconsistency because they are usually nicely behaving. So take this logic MBC with these connectives, expected connectives, plus a consistency, and then it has the axioms and rules of deduction of the positive fragment of classical propositional logic, plus tertium non datur, plus, that is very important, a controlled explosion law that says that if a formula is consistent and it is true, and negation is also true, then you trivialize an argument. It is not enough to ask alpha and non-alpha to coexist. You must also assume that alpha is a well-behaved formula. A few other logics of formal inconsistency we will use: extend MBC by addition of respectively these axioms. I can explain a little bit more about them later, but that's not the main focus of what I have to say right now. Now, a logical matrix, that is a very important notion here, is a pair formed by an algebra and a subset of its universe called designated elements. They are the truth value, the true truth values of the logic at hand. So a matrix induces a consequence relation when we define it like this: gamma proves phi according to M, if and only if, every time that evaluation is a homomorphism of this form, maps the premises into designated elements, then it also maps phi, the conclusion, into a designated element. Well, if we have a class of matrices, we have a consequence relation by simply intersecting all previous consequence relations. All is well. Now, we can generalize a matrix by changing A into a multi-algebra. This becomes a non-deterministic matrix or N matrix. We can also instead add a third coordinate to a matrix composed of homomorphisms, of valuations of these homomorphisms here, some of them, and then this triple is called an error matrix or restricted matrix its creator, Piocchi, named them E matrices, but we prefer to call them R matrices. And then how this endorses a consequence relation? Well, gamma proves phi according to M, if and only if, for every one of these restricted valuations, if the premises are all designated, so is the consequence. Now, we combine both notions, N matrices and R matrices, and we produce Rn matrices. A is a multi-algebra, D is a set of designated elements, and F is a set of valuations. Now, it's very nice in a sense because every Tarskian logic can be characterized by a two-valued Rn matrix, but that does not mean that we have a decision method. We shouldn't hope for that. But we still have a two-valued characterizing Rn matrix. That's very nice. Now, a few semantics found in the literature can be recast as Rn matrices. So, current semantics without possible words to modal logics, these are quite obviously Rn matrices when you look at it. Fido structures as well. Static semantics by Avrona and Konikovska, they are Rn matrices in a most obvious way. Pn matrices, that is partial non-deterministic matrices, they are Rn matrices as well, but that's a bit harder to see. Bi-evaluations are Rn matrices as well. So many semantics can be recast by using this formalization here. So what we can do with these semantics? Well, we characterized a few logics in chapter 4 of the thesis, like MBCCL. But now we would like to move on to the Costas hierarchy of logics, which is much harder. Well, Cn has these connectives, the axioms and rules of inference of the positive fragment of classical propositional logic, plus tertium non-datur, double negation elimination, gentle explosion law or controlled explosion law. But here we don't have a consistency connective. We have a more complex formula, which we define formally here, but it's essentially an N consistency. So if alpha is N consistent, then if you have alpha and not alpha, then it follows anything. Plus, N consistency is propagates through the classical connectives. That's what these axioms say. So these are the logics Cn, and they can be nicely characterized by bivaluations. What are bivaluations? Bivaluations are functions from the formulas of Cn 2, 0, 1, and gamma proves phi according to Cn if and only if for every bivaluation B, whenever the premises are all 1, then so is the consequence. I can explain a little bit more about bivaluations in the end, looking at the thesis. Now, consider the n plus 1 tuples B of alpha, B of not alpha, B of alpha 1, through B of alpha n minus 1. Here is not the n consistency, but is a step in defining the n consistency, this index here. And B is a bivaluation. And if we define these tuples, we find that there are n plus 2 of them, namely Tn, T0n through Tn minus 1n, and Fn. These are called snapshots because they capture an exact moment in the logic. That's our rationalization of the name, snapshot. All of them, the set of all of them is called Bn. The designated elements are all the true, the T's. The Boolean snapshots are the uppercase ones. So Tn and Fn. These are the classically behaving ones. Look that alpha and not alpha are not simultaneously true in them. And finally, the inconsistent ones are the non-Boolean ones. Well, we can make these these snapshots into a multi-algebra by defining operations like this. How you find these tables? Well, you have to remember that Cn propagates consistency, so the corners must be single-valued, and then in the middle, you will usually fill with the set of designated snapshots with a few exceptions. That's a way to see how these tables are found intuitively. So, well, we can hope that these multi-algebras characterize Cn because at least C1 is not characterized by n matrices. But if we add a few restrictions over valuations, we can prove that for any bivaluation B, this function is a restricted valuation, and for every restricted valuation, its first coordinate, it is a bivaluation. And then by use of these lemmas, we found that this finite Rn matrix with universe, this set of snapshots, operations like this, and restrictions like this finite Rn matrix characterizes Cn. So that's very nice. We have a characterizing Rn matrix. Well, when we have a finite matrix, we have a truth table. When we have a finite n matrix, we have a row branching truth table. When we have a finite Rn matrix, not always we can find a truth table. But when we do, we have a row branching, row eliminating truth table. That is, we must erase a few rows because they correspond to non-restricted valuations. Here, the conditions for a row to be eliminated in Cn are very simple, and they can be performed algorithmically. So what we have is a decision method for Cn based on, well, it is a kind of truth table, a generalized truth table. That's very interesting. It is a reasonably effective decision method for Cn, and a very new one because it is based on a new type of semantics, these Rn matrices. Well, looking at excuse me, just a moment, looking at these tables of operations, we can define tableau rules. Now, we also have restrictions over the valuations, and these translate into conditions for a branch to be closed in this calculus. What we get then is a tableau calculus capable of characterizing Cn. It's not the first one, but it's one of the most algebraic ones. They are the rules of the tableau rules, at least, are very clearly extracted from operation tables. So that's also a new decision method for Cn. And now now one could ask, okay, we have studied a lot of Arran matrices for CN, but they are all based on the two-valued Boolean algebra because we are looking at bivaluations. So can we generalize that? Yes, we can. The answer, why should we do that, is because there are very model theoretic implications in having these more general structures for CN. So first of all, taking a Boolean algebra B, we define a B evaluation. I call bivaluations instead of B evaluations, which I think is a more common way to spell out their names, because I wanted to make this distinction between bivaluations and B evaluations. So a B evaluation is a function from the formulas of CN to the Boolean algebra B, satisfying these conditions. It is true that B evaluations characterize CN. That's very nice. Furthermore, we define snapshots based on B evaluations as we did for bivaluations. Okay, this is not the definition I shown earlier, but it's equivalent. We show like this because we need a bit more formality here to avoid confusion. But it's the same definition. Designated snapshots are the ones starting with 1, and Boolean snapshots are the ones corresponding to formulas where alpha and not alpha are not simultaneously true. So Z1 and Z2 equals 0. We define the multi-operations over this set of snapshots in the same way we did for bivaluations. Here, again, we have to be a bit more formal because there are many more snapshots than there were before. Well, these multi-algebras cannot characterize CN, but by adding a few restrictions over evaluations, we get a class of Arran matrices that do characterize CN. How we prove that? Well, in the same way we did before, taking a B evaluation B, defining a function like this. It is a restricted valuation, taking a restricted valuation, and its first coordinate, it is a B valuation. So these structures generalize the former Arran matrices we have defined for CN. But again, why do we define them? Well, here is why. We can't take this class of restricted swap structures. Swap structures are structures, are semantics that where negation swaps positions. That's the main idea. Why the name? So we take these restricted swap structures over any non-trivial Boolean algebra, define nice morphisms between them. What are the morphisms in this context? These are homomorphisms that preserve designated elements and that are absorbed by restricted valuations. Well, these morphisms are very easy to characterize. They are of the form psi z1, psi z2 through psi zn plus 1, where psi is a Boolean algebra homomorphism. And then, by using this characterization, we can show that the category of non-trivial Boolean algebras is isomorphic to this category of restricted swap structures for CN. So there is a very nice model theoretic background for this. Well, they are essentially models for CN in a new sense, of course, but they are models for CN. and they are a very nicely behaving category of models. So now it says is on. I will
Okay,
just a
go on.
second.
Okay, you can continue.
Yeah. Well, it says is on. I don't know if we lost a little bit of the presentation, but I think it's.
Don't worry. Go ahead. Go ahead.
Yeah, there's nothing we can do about it.
No.
No problem.
Yeah.
Please
No.
So, okay, let me continue again. Sorry for the second interruption. Let me just. Now I'm finishing the presentation already. So the last chapter of the thesis is devoted to translating paraconsistent logics. So I said that the axioms of these new logics of incompatibility I defined mirror those of some logics of formal inconsistency. We can formalize that. So we define a function t from the formulas of MBC to the formulas of NBI such that it keeps variables the same, it keeps negation the same, it keeps classical connectives the same. The difference is that consistency is translated, as I mentioned before, as incompatibility with the negation. We can show that T is injective, but furthermore, we can show that T is a translation, meaning that if gamma proves phi according to L, then the translation of gamma proves the translation of phi according to L star. What is L star? Well, here we have only modus ponens as the deduction rule. So L star is basically the logic obtained by translating the axioms of L. So we have this very nice result. T is a translation, but for these logics we worked specifically with, T is also a conservative translation, meaning the reciprocal is also true. To show that, okay, the proof is in the thesis is a bit involved. We need to use bivaluations for both inconsistent systems and incompatibility systems. We make a translation of bivaluations. We use a few intermediary systems, but it works, and we show that T is a conservative translation. What that means? That means that the logics of incompatibility we have defined here generalized in a non-trivial way these logics of formal inconsistency. So we are all actually working with something new. It's not just a new way of looking at things, but it's a way of looking at new things as well. So, well, this ends the topics of the presentation. So I talk here a little bit about future work. I know my time has run out, but we had a few interruptions. I ask you to be patient. It's just 2 more slides. Well, what we hope to still study in multi-algebras. We have defined a generalization of absolutely free algebras. We would like to keep studying on that. we would like to perhaps achieve a theory of multi-algebras analogous to the theory of universal algebras. That would be a very nice result. It seems like a very difficult result, but intermediary steps seem achievable. Looking at our alternative for non-deterministic semantics, we could attempt to translate non-deterministic existing non-deterministic semantics as sigma-ordered algebra semantics to see if something new pops up. Now, more importantly, in logics and non-deterministic semantics, a general theory of Aryan matrices, similar to Bloch and Pigos's theory of algebraizability, would be nice, very nice, actually. An easier step would be to characterize a few other logics with Aryan matrices. Model logics seem like a natural step forward. We would like to look at the efficiency of decision methods obtained through Aryan matrices. We would like to look at the Costa's logics from a categorical viewpoint, since now we have a very nice category of models for these logics. We would like more philosophically relevant incompatibility systems. And finally, we would like very much to know what logics can be characterized by nice Aryan matrices. Okay, we know that all Tarskian logics are characterized by Aryan matrices, finite ones, but we would like to have nice Aryan matrices. That is to lead to decision methods and so on. This ends my presentation. Sorry about the delay. Sorry about the 2 interruptions. Here I have listed all the references found in the thesis, but I think it's much easier to look at them at the actual thesis. And this finishes what I had planned to say.
Thank you very much, Guilherme, for your presentation.
No, I thank you people for...
No problem, it's like outside our scope. It's the technical problems are there. We don't control them. Okay, then we will start the revision to the candidate, Guilherme. And we will start by inverse order of distance. It's a tradition here at Unicamp. Then we will start with Anna Samansky with University of Haifa, Israel. Anna, thank you very much once again for your nice participation in this session. And I would like to ask you for a question to the candidate. Okay?
Oh, thank you. Thank you, Guilherme, for a wonderful presentation. I would like to also congratulate you and Marcelo for achieving such nice results, because characterizing the coastal system is a long-standing problem, and a lot of people attended different approaches, attempted to do so. So I think it's great achievement. So congratulations to both of you.
Thank you, Anna.
Thank you. Thank you very much.
Yeah, I'm excited to read your work and to hear the presentation. So I will ask a few questions. I have many questions, but I should also leave room for other people. So my first question is about the notion of negation that you assume in the paraconsistent logics that you focus on. So as far as I understand, you assume that you have a unary connective like negation. And yes. I would like to better understand what are you assuming about this negation? I mean, what would be the most general notion of negation that would still allow your nice results to hold? Because you have, you said that this negation should satisfy the principle that from alpha and not alpha, anything follows. What other properties of negation are consistent and appropriate here? For instance, involutive negation. So negation A implies A, or A implies double negation A. Law of excluded middle, whether it's possible in maybe some weakened form. So what are the properties of negation that you really need for your results? Because of course we would like to have your results as general as possible. Yeah, so that's my first question.
Okay, looking at the different results, so if we look at the logics of incompatibility, the translation of the logics of inconsistency to logics of incompatibility. Of those, all we ask of negation is what we have asked of MBC. That is, that we have tertium non datur and a controlled explosion. Tertium non datur actually doesn't seem necessary, so we could exclude it from our logics of incompatibility and exclude it from our logics of inconsistency as well. But the controlled explosion is actually what we are trying to achieve by looking at incompatibility, at least a generalized form of controlled explosion. So if we were to remove the controlled explosion we found in MBC and related systems, well, I don't know exactly what we would be achieving. I really don't know, because we haven't looked at that. Our logics of incompatibility, we built them thinking about controlling the explosion of incompatible formulas. Well, if we remove that, the only left property of incompatibility would be commutativity, which is not a lot. Now, for characterizing Da Costa systems, which I think it was the main point of your question, we have applied this procedure of producing swap structures, restricted swap structures, for a few systems, not a lot of them. So basically, Da Costa systems and MBCCL. MBCCL is a lot weaker. So what are the properties of MBCCL? There's tertium non datur, there is controlled explosion, and there is the XMCL. I can't remember it right now, but I can look at the slides if it's better. So we have that this procedure works for some quite weak systems, but we don't actually know what properties of negation make it work. For MBCCL, the idea behind swap structures was to consider triples of alpha, not alpha, and the consistency of alpha. What makes a lot of sense. MBCCL talks really about the truth values of a formula, its negation, and its consistency. So I think asking about what would be the most general negation that works for this procedure, it's one of our open problems. What logics have nice Arn matrices? That is actually our main question in the future. What makes it work? Well, the Costa systems has a weak negation, but a stronger negation than NBCCL. So I think the best example of weak system we can apply this methodology to is NBCCL. It has a quite weak negation, I think.
Yes, thank you. Thank you. You have answered my question. I did not mean for you to give the answer now. I just encourage you to explore it more because I think it's very interesting.
Sorry, I don't know how Marcelo wanted to proceed. I think we can do this back and forth, or
Yes,
or
yes.
better.
As you prefer. As you prefer.
Okay.
Sorry. So that's it from me, or can I ask something else, or should I?
Oh, I think there's plenty of time to ask more. I think
Okay.
Marcelo planned at maybe an hour for everyone. I don't think everyone is going to use a full hour, but 2 hours for Walter.
Walter has. Okay, so just one more question from me, if I may. I did like your answer about the properties of negation that make it work.
I explained it well.
I'm very curious to see whether you find an answer to that. And also concerning the notion of Rn matrices, which you introduced, which is very interesting and a new concept. So as you know, non-deterministic matrices, for every such matrix, we can have a proof system that characterizes the logic. Would you think it's true also for this new structure? Because
very interesting question. We are working on that. Okay, we have brought a specialist in proof systems to work with us. We think it could possibly be perhaps a generalized notion of proof system. We are not sure yet. We believe something very closely related works. We are dealing first with Rn matrices for the Costa systems, and then we plan to holds for other nice Rn matrices. We can hope to hold for all Rn matrices. As I mentioned, they are sometimes too general. They sometimes don't even lead to decision methods. But we believe that at least for nicer Rn matrices, we should be able to reach proof systems. That's ongoing work. Just a comment. We believe we have co-discovered Rn matrices, or at least we think that Pavlovsky and Urbaniak were saying almost the same thing as we did in an article that was published in the same time frame as ours. We believe that our definition is a little broader, and our applications are a little more systematic. But since then, we have found a few very nice, very recent applications for Rn matrices, including in the work of Gratz. Just a comment that seemed appropriate to make now. It seems that Rn matrices are becoming very popular. People don't call them that, and people don't use them in their full generality. And okay, related semantics go back to Kern's work, and possibly even earlier. But I believe we are seeing a boom in applications of Rn matrices, including to very difficult open problems that were standing for ever. So I hope I have answered the question regarding the proof systems.
Yes, thank you. You answered. It's very interesting to see where you go there. I guess the most complex thing is this this F, this set of things that
Exactly.
is infinite, and you need to deal with it, with the infiniteness of F.
Exactly.
Yeah.
The problem is the power of Aryan matrices come from this F, but also their inner difficulties come from this F. That's why we believe that Piocchi's work on E matrices was not very successful. People looked at N matrices and people looked at E matrices, and they said, okay, N matrices are much better. Okay, and Piocchi's work was a little overshadowed by other semantics. But we believe that it's actually very powerful. We are talking about with a few people about looking at E matrices as well, because they are not very well studied. It seems interesting too. They are not nearly as powerful as Aryan matrices, but they have nice properties as well.
Okay, thank you very much.
No further questions? At least not for now. Okay.
Thank you very much, Anna, for your very nice contribution. And then I would like to invite Hitoshi to talk, to make her suggestions or comments arguing the candidate.
So, well, before starting, I mean, Marcelo, are we going to be taking rounds? Like, would we just be doing a few rounds, or are we supposed to just ask rounds?
No, it's each member of jury to talk by its time.
I think you can ask all questions that you have, but if some other question comes up later, there's no problem in asking it later. Yes, we can do a new round in the end if it's necessary.
Everybody's invited to talk again, of course.
Okay, wonderful. I mean, I must do the same thing as what Anna did, just to congratulate Guilherme and Marcelo for this wonderful work. In particular, I totally agree with Anna that this C-systems part is absolutely beautiful, I think. You know, this is just great work. So thanks for letting me see these things in advance in some sense, and seeing it live. This is a wonderful and an honor for me. So I would have questions here and there, of course, especially the logic part, as you probably expected me to comment on. But I can start by following up a little bit on Anna's question, right? So this Rn matrices is great, right? This is highly non-trivial. But I'm having this kind of picture, like if you start from the positive classical logic with just the paraconsistent negation having the law of exclude middle, which is basically CLUN or PI plus something in a number of different ways that people know. There we have a very simple non-deterministic semantics, as Anna and Arnon and Arthur have been working on, right? 2 valid non-deterministic semantics or 3 valued, we have it, right? And then on top of that, there are some extensions that you get. In between, there's going to be C systems, whole hierarchy, right? But then if you go far beyond that even, there's going to be systems like set this P1. So on the way, you get to some very simple systems. Again, 3 valid logic, deterministic, right? Ending up in a 2 valid classical logic, right? So what happens, it seems, is like we start from a very simple system. Let's say let's assume the the law of exclude middle with respect to paraconsistent negation, right? There you already need some bivaluation semantics, but I want to just focus on the non-deterministic semantics sort of things, right? So we have the simple thing. And then at the stronger ends, there's also some deterministic or non-deterministically well-behaving systems. In between, there's the systems that we all been knowing that beautifully formulated by Da Costa, posing a lot of challenges. And you've basically shown that there we need not only the non-deterministic matrices, but the restricted versions, right? Now, I'm just curious if you have any sense, what is exactly the source of this difficulty? What might be the reason, right? Because if you go really strong, you don't need this anymore. If you're really weak, you don't really need it either. So there's something extremely interesting happening in between. And I'm just wondering that because you're the person who established this result, a wonderful result, I'm just trying wanted to ask what might be the things that is causing this difficult thing, or what might be the kind of logical aspects of C systems specifically that is producing this things. I mean, you can also address the same question with respect to LFIs, right? You can take the consistency operator on top again. It's the same, I think, right? We start from somewhere simple, non-deterministic semantics, even with finitely many valid suffices. If you go really strong as LFI 1, again, it's a deterministic. And then there's going to be something in between. So there's the same pattern here and there. I'm just curious if you can say something about some guessing from your end. But as the true experts, knowing about this topic, the best in the world so far, seeing this landscape in what sort of ways? Or if I'm seeing this thing in a different way than you are, I'm just curious what you would say about this.
Okay, very interesting question. I think very difficult to answer. I will start by saying that part of the problem, as I said to Anna, is that it is still ongoing work. We would like to know why some logics can be characterized by nice Aryan matrices, others cannot. So this is part of a great program in understanding Aryan matrices and, of course, other semantics better. So, but to answer about this gap you mentioned, this difficulty gap, we can at times point out exactly where the problem lies. I will use logics of incompatibility for a simple example. So I showed that BI cannot be characterized by finite n matrices. And it's actually a very difficult logic. But if we remove the commutativity of the incompatibility connective, then it is characterized by a finite n matrix, a two-valued one, actually. So for logics of incompatibility, we know precisely where the problem lies. Actually, Marcelo was the one that suggested strongly that we add commutativity, and the thing became much more interesting than it was before. Without commutativity, okay, we had n matrices, that's interesting, but not very much so. And then we added one axiom that made everything much, much, much more difficult to deal with. So, okay, we can pinpoint exactly what is the axiom that's causing the trouble, all the trouble. But I don't think your question is about okay, what one axiom is causing the problem. I think your question is more about what properties of the logic, what logical properties of the logic, what algebraic properties of the semantics cause this gap. And this we are not really sure. It is clear that the gap exists. So you have very simple logics that are characterized by nice semantics, and then you have much stronger logics that are characterized by nice semantics, and in the middle you have logics that are not. We can sometimes pinpoint the axiom, but we don't have yet an idea of why it is a philosophical, a deeper understanding of why this is happening. I think it's a very difficult problem that would involve a much better understanding of RN matrices and where nice RN matrices start working, where they do not. It's a very difficult question, I have to say.
Well, I meant to ask the experts, you know? So I don't expect everything is going to be answered already now. But so wait, so hang on. So what you just said is basically if you drop the symmetry condition, it's going to be right. I see. So for example, if I may ask, just follow up on what you said, which is extremely surprising again. For example, if we don't get the full symmetry, but only with respect to the, well, consider the language with the power consistent negation being added, if we just add the symmetry with respect to A and not A, power consistent negation A, would something similar happen or not? I mean, because the costless C systems have this property that you don't necessarily have under power consistent negation, A and B and A are equivalent, right? But when it comes to negation, power consistent negation of A and not A, it's different, right? So I'm just curious, would you have you thought of that specific instance?
I have to be honest, no, at all. But that's very interesting to consider.
Yeah.
And I didn't have the time to write this in the presentation, but I think it is in the thesis that we are looking at difficult systems to better understand where is the separation between, okay, these systems are characterized by that, these other systems are characterized by that. And I would guess that this system you suggested, it's probably very difficult, and it would fit nicely in some niche in this whole characterization process we are looking at. Very interesting question. I hadn't thought of it. We only thought about the full commutativity, the full symmetry, and as I say again, the incompatibility systems were very boring. Between Marcelo said, okay, incompatibility is always symmetrical. You have to add this axiom. It's incredibly natural. And then things became so much harder to work with and so much more interesting than they were before. Before, we didn't really think that logics of incompatibility deserved to be published. Now we are very happy with the article we have produced about them. We are very happy about it. So, very nice suggestion. We will try to study the system. It seems very difficult. I don't know, Walter.
Walter.
Can Hitoshi? Can I add a comment? Just an intuitive comment. Things are, in my opinion, are more or less like non-commutative algebras, right? Non-commutative algebras are very general and they apply to many other systems. When you force everything to be commutative, then you have very few examples, like fields and rings and things like that, and groups. So that's the problem. So nature is not really symmetric. Yeah? When you consider non-commutativity, you have more freedom. You have more models. That's maybe one of the intuitive explanation. That's just a comment.
Yes, it seems natural because when you look at Fido structures for BI, that is the incompatibility logic with symmetry, and BI minus, that is the incompatibility logic without symmetry. Then all Fido structures for BI are also field structures for BI minus. But then you have other models for BI minus that include a finite characterizing N matrix. So yes, perhaps that's part of the explanation. But as I said, okay, in a few contexts we have the axiom that causes the problem, but why it causes the problem, a deeper understanding of that, well, we would like to achieve one day, but it's not yet with us.
I would like to add a comment to this extremely interesting question by Hitoshi is that a very delicate point. As Walter will recall, when we prepared our book with Walter, in chapter 6 is dedicated to non-deterministic semantics. We introduced the swap structures in the final form, and we discovered that point that you have mentioned. If you start with a very simple logic at the PI, as you say, and you have a non-deterministic semantic by evaluations, for instance, then you add more actions, then the natural route, the natural ways, when you add actions, that non-deterministic semantics is getting more tight until achieving of a three-value logic, and finally classical logic. It's very natural. What happens in the middle with the CL actions by Da Costa? Doom. You in the middle of the way you don't have any more finite non-deterministic semantics. It's very strange. What happens in the middle? Well, in that chapter with Walter, we try to explain or try to justify what happens, but without giving more concrete solutions to this. We just declare our admiration for discovering such a phenomenon, which is very unnatural, we could say. After this, we discovered with Guilherme a way to restrict the N matrices by defining our N matrices. Then what is the solution? Well, in the model is the same, is N matrix. Okay, finite N matrix. Then we restrict the evaluations. If you restrict evaluation, the logic is larger. Then you can obtain capture exactly the truth that you want. In this case, C1. But it's very strange phenomenon. We don't know at what point or what causes. In the case of Da Costa, we think, well, maybe since we are the law is the negation, not alpha implies the consistency of alpha. Then since we are combining a negation inside the negation, maybe this iteration causes this phenomenon. But it's not the case, because there are a lot of other LFIs with equally complex actions, and the semantics is a finite N matrix. Then, and now we have the new brand example of the logical incompatibility. You add simply the commutativity. I am guilty for that because I think that is very natural. Say, well, compatibility and incompatibility should be symmetric. Of course, you can deal with the symmetric incompatibility relation, but it's a bit strange.
Or partially symmetric. Now this idea.
Very interesting, Hitoshi, your suggestion of considering that restricted incompatibility symmetric law. But then, well, it's a mystery. We don't have an answer, but the point is, as you have pointed out, it's very strange what happens in the middle, very unnatural in some sense. Thank you for your question.
No,
Okay.
and I mean, I can of course continue more, but I can't resist to ask this one. A very specific question. So in chapter 7, when you do the logics of formal incompatibility, you do talk about Brandom quite a bit in an interesting way. And if you for the thesis I got on page 230. Sorry for being so specific, and maybe some of the audience may not have.
Just a second. 230.
Yes. There is this one axiom saying like if A and B, alpha and beta are incompatible, and then beta is implied by gamma, then alpha and gamma should already be incompatible. And this, I really find it natural. And I think this is something that Brandom and many people who works in this incompatibility related things will be happy to accept. So I just wanted to ask you, what might be the semantic impacts of this axiom in the Rn matrices? Would this kind of be, again, making things strong enough so that the restriction is not necessary? Or you think that this might still require the restriction? I'm just curious if you have any sense of this specific axiom having any impact on your semantic treatment.
Unfortunately, no, we don't know yet. Okay. Because as I said, we tried many logics of incompatibility. We tried to model notions in natural language, and okay, we produced a vast array of logics, but we couldn't study all of them. So we started with BI minus, then came BI, one that is in the thesis, which I don't find very interesting actually. BIPR, that has a propagation of incompatibility. Then came NBI, NBI-CLEW. But as I said, we are looking at the literature in incompatibility to find better axioms. So exactly, Brandom has a lot of very interesting ideas. He has already formalized many notions in natural language regarding incompatibility that we would like to add to our systems. So this is a very natural axiom, as you said, and a very nice one. It seems difficult to work with, but we still don't have a logic that actually works with this axiom. Okay, we don't know if maybe an N matrix is enough, or because we have this new way of looking at things, perhaps an A matrix is not enough, but an R matrix is enough. So there's a new direction in which you look at things, or maybe an Rn matrix is necessary, but we don't know it yet. Interesting that you found one specific axiom that is very interesting, but we have no idea about it yet. Sorry.
No. There's no need to apologize, of course. I think I would just try to press you that you teach me in a few months' time or so about these two specific extensions of this.
We will look at this logic. Both suggestions seem to lead. I don't know, but I would guess that they are very difficult systems, and that makes them more interesting. Easy systems are not very interesting. But okay, this is a very nice axiom. I will look at it more seriously now. Now that we have corroboration that we should look at it. But okay, Peregrine has a lot of ideas as well. O'Connor has a few ideas as well. O'Connor's are a little bit more philosophical. Peregrine's are a little more technical, and Brandon is in the middle. I think all of them can contribute a lot to what we are studying here. I hope I have answered. I know the answer is we have no idea, but I hope I have explained why we have no idea yet.
No, absolutely. This is all very great, and I can actually continue for 1 more hour, 2 more hours, but I shouldn't. So I'll just pass it on to the next member of the jury. So thanks a lot. It was great.
Oh, we thank you.
Thank you very much, Hitoshi, for your very, very interesting question and very interesting suggestions. I writing everything here. Thank you very much. Thank you very much. Okay, well, I would like to invite now the next member of the jury, Darlan Conceição Pinto from the Federal University of Bahia. The next one in terms of
sorry, I understand the last member of the jury. No,
the next. Sorry,
the next. Oh, sorry, I misheard.
The next in the order distance, inverse distance. Darlan from the Federal University of Bahia, Salvador. Thank you very much for being here.
Oh, thank you, Marcelo. Thank you, Guilherme. Thank you for inviting me to be here as a member of the jury of this wonderful thesis. It's some very big thesis. I'm sorry about my English, but I will try to explain everything that I think about the thesis. So I will be so few comments about the thesis, and was wonderful. The first part of the thesis was my main interesting of the thesis. It seems almost disjoint with the second part, but I believe that in the future this connection will be more strong, and I can see that in the reading the text. It's very good. The results is very original, and the thesis is very well written. The mathematical results is very precise, and for me it was very easy to read the thesis. So just a few comments there. When I was reading the thesis, and was also tired, and I could see your photo in that was okay. I relax and keep reading the thesis with more easy way.
Yes, that was the idea. Sorry, the thesis is very long. We know that. We are okay. We tried to fit a lot of things. It ended up being a monstrous text. And I thought, okay, maybe a beautiful picture may distract people from this Herculean effort that I put them through. So thank you. I'm happy that it helped at least a little bit.
No, but very good. I like it. So I have so few comments about the first part and the second part as well, but about the first part. So the first part, you are looking for a good notion of free algebra or free multi-algebra, and that's a key part to an algebraic analysis of the logic.
Yes.
Okay. So when I was reading, and you have proved the adjunction between the M sets and the multi-algebra with multi-homomorphism, with equality. Okay, and this provide a free multi-algebra. And I was thinking, okay, have some good thing here, because with a free multi-algebra, we can use that to analyze the logic with an algebraic counterpart. But you have said in the text that this adjunction is not useful and the logic that you apply. And I would like to know why.
Let me find this. I think it is in the first chapter.
Yes.
Yes. Let me just.
In the section 1.2.2.
1.22. Let me see. Okay. Yes, there is a. They are not, yes, and at the same time, they are not very useful to most applications in logic. Yes. Let me start. Thank you for the comments. Let me start by saying something I find it very important. You said that parts 1 and 2 of the thesis are kind of disjoint. Yes. Sadly, it is true. We had a few ideas in logic. We had a few ideas in algebra. We attempted to connect them, but the connections we found were okay. The third chapter has a slightly stronger connection to logic, but not very much. The second chapter has very nice results, at least according to us, in multi-algebras, but it has nothing to do with logic. And yes, we attempted to connect them, and so far we failed. So yes, we feel that there is a connection missing here. We hope, as you said, to apply these weakly free multi-algebras to semantics in the future, but this has not yet been accomplished. And it seems like something really important and at the same time very difficult to achieve. So yes, that doesn't make me very
That was
happy
just
about
a
this.
curiosity. Just a curiosity.
Chapter 2 is kind of isolated from the rest, but we still find it interesting. But now, to your question, why full multi-homomorphisms are not... The reason why this equivalence of categories is not very interesting is because we are using full multi-homomorphisms. We attempted to use them for semantics, but they aren't as useful, or at least they are not as well studied when looking at semantics as, for example, legal valuations that are simple homomorphisms instead of full homomorphisms. We know that you and Hugo and Peter and many and Kaique have been studying how to better connect semantics and the understanding of multi-algebras and hyperalgebras found in the usual mathematical literature. So hyperrings, hypergroups, and I think we have discussed this. There seems to be a disconnect between logicians and mathematicians. Mathematicians prefer to look at things that would amount to be full multi-homomorphisms and some related concepts, while logicians seem to look at things in terms of legal valuations, or in the terms I have used throughout the thesis, homomorphisms. We don't know why one thing appears to work so well with mathematics and the other appears to work well with logics. We don't know that. It's really a mystery. I think you people find it a mystery as well. Okay, we have this equivalence using full multi-homomorphisms. But because logics prefer legal valuations, these full mutual homomorphisms and their equivalents are not as useful to us as it would be to find something using legal valuations, which from chapter 2, we know that actually doesn't exist. So, of course, this may have applications this equivalence may find applications in mathematics, in either hyperrings or hypergroups. I'm really not sure. I'm not that familiar. But in the other direction, let me say that this result was more of a commentary. I think it is an accessible result. Someone must have found it. I couldn't find in the literature because we use terms that we coined them ourselves. So full mutual homomorphism, no one calls them that, I think. So this result should exist somewhere. We just don't know about it. So perhaps someone already has said a few things about their applications. I can't say a lot more about it. Sorry.
No.
I would like to add a comment to
Okay.
your question, Darlan. It's very interesting question. Why this difference? In hyperalgebras, you can use that notion of full homomorphism. It works of joining up all the interactions between the elements when you combine multi-operator, it works. But in logic semantics, does not work. There is a very nice example in the PhD thesis by Ana Claudia Golzio.
Okay.
When she shows that if you take, for instance, the excluded middle, P or not P.
Yeah.
If P takes a single value, it's a proportional value, then by means of a legal valuation, it takes a single value. Okay. Then you compute, let us say, P or not P in this multi-algebraic environment, and it produces a set of designated values. Perfect. It is a tautology, assuming that the logic satisfies the excluded middle, then it is tautology because it's a set of designated values. But when you applies substitution, then you replace P by the complex formula, then P does not get anymore a single value, but a set of values. In other words, if you compute in this multi-algebraic environment X or not X, where X is non-empty set, then if you mix everything, you get the designated and also non-designated values. Then for logic, this is a disaster. That's the problem. In logic, we besides the multi-algebras, we also have a link, let us say, with designated values. We need to be linked to designated values. And then if you mix everything, then you lost that property. That's the problem. In hyperalgebras, they don't have that problem because they are not thinking about a set of designated values or privileged values. This is an intuition of why it does not work. Just an intuition. As Guilherme said, we don't have a concrete answer for this phenomenon. But it's just an intuition why it does not work in logic. Because the designated values, we suppose, that is motivation, that is a possible explanation for the phenomenon.
Yeah, I remember that you said for us before, and I forgot about that, but it's true. Thank you. So, can I keep with some comments?
Yes.
Okay. So you have proved isomorphism between algebras with an order, no? And so the category of algebras with an kind of order with
Yes.
some, and the category of multi-algebras. And I
Yes.
believe that this isomorphism could be useful to give an analyze to some logics with order algebraizable logic, order algebraizable.
Yes. Yes, that
Yes,
occurred to us as
so,
well,
yeah.
but sadly, I'm not that familiar
Okay.
with ordered structures that well to have actually started something. And oh,
Live streaming is on.
is on. Okay, okay. Now we can continue. Yes, I thought a little bit because there's literature in ordered algebras and so on, but I'm not that familiar with. Uh, it is a possible direction for future work, but I wouldn't be able to comment a lot on that. Actually, just a curiosity, I thought about removing the third chapter from the thesis. I got discouraged by Hugo. Hugo, in my qualifying exam, he insisted that, oh, this is interesting.
Exactly.
Maybe you don't find it interesting, but I find, and you should believe me, that it's interesting, and you should keep it in the thesis. So,
Yeah, me too. It's very interesting. Yeah.
So I can't comment more. Sorry about this
No.
connection.
Yeah, it's okay. No, just just a suggestion. It could
Yes,
be useful to give an order algebraizable treatment for some logics with
yes,
that are not algebraizable, block bigots algebraizable, like BI, for instance. I believe that
yes.
could be useful. So
That seems very challenging as well.
in the second, so just another suggestion, and in the final of the first part, I could see, I would like to see some diagram with the all functor among the categories that you proved here. So it could be
Oh,
useful
that's a nice idea.
for us to
A big
analyze.
diagram showing a few connections.
Exactly.
Yes, yes, that will help a lot in understanding this very technical chapter. Okay,
Okay.
noted. That's very interesting. That would help a lot.
And so about the part two, I have some. I will send a PDF with some comments and corrections that will.
Oh, that's very helpful.
So, but just to talk about the final part and then the connection with block algebra, block Pigotzi algebraizability.
Yes.
So that we have a meet like 1 year ago talking about everything.
Yes, an attempt to generalize block and Pigot's algebraizability.
Exactly. So I believe that here we have an almost new idea, because when you are proving, I believe that BI is incomplete with Fidel structures. I don't remember exactly if it was that. You have
it's characterized by a class of Fidel structures.
Exactly, and you will have proved using this technique like a linear bound task technique.
Yes.
So that is the idea behind the block Pigot's algebraizability. And I believe that it's possible to generalize this construction and give a new notion of a multi-algebraizability. I think so.
Oh, that's very interesting. I hadn't thought about it, but yes, it's a Lindemann-Tarski structure to which you add very carefully a few non-deterministic operators. It could be generalized for perhaps not all systems, because as I said, you need to be very careful when adding this non-determinism, but maybe it can generalize for a larger class of systems than Bloch and Pigozzi algebraizable systems. Yes, I hadn't thought about it.
No, but I believe that would be because you have an example. Because
Yeah,
PI is not a block
it
because
works. It works. So you know it works. Now you just have to formalize it to work. Oh, okay. As I said, we would like very much to have a theory of Arran matrices similar to Bloch and Pigozzi's. And maybe that's one direction, considering generalized Lindenbaum-Tarski structures, perhaps not to all logics that are characterized by Arran matrices, but some logics that have a nice enough incompatibility, no, but non-determinism. Okay, that's very. We hadn't thought about. We are trying to look at a full theory of Arran matrices, but that's a little too much. Perhaps start with these Lindenbaum-Tarski structures and then move on from there. That seems more achievable to us.
yeah, yeah. And just a last comment. You have proven isomorphism between the Boolean algebra and the restricted swap structure.
For CN,
No?
yes.
So, could use the fact that Boolean algebra is a reflexive subcategory of the category of sigma structure on the signature of classical logic. And I mean, Boolean algebra is a quasi-variety, and how can translate some property of the quasi-variety to R-swap structure that we are working here, and this could be interesting as well.
We've thought about exactly the same thing. We have great plans for this category for CN because it was really surprising to us that such a strange category would turn out to be isomorphic to such a nice category, closed by amalgamation, with other properties that have nice applications in logic. So you can prove Craig's interpolation by using amalgamation of the characterizing variety. So could we perhaps translate amalgamation in some way to swap structure, restricted swap structures, and obtain properties for CN? We are thinking about that. It seems very difficult to do so, but it's very worthwhile because we would have there is a ton of results using the structure of categories. So Beth definability, Craig's interpolation, there are other interpolation results using properties of amalgamation. Exactly. We are very interested in that. And furthermore, we started working a bit more on restricted swap structures for CN, and we discovered actually that we can weaken the restrictions of evaluations, and then you don't get such a nice category, but you still get a very nice category. So it's very strange that working with such a difficult system as CN is turning out nice categories. It shouldn't. It really shouldn't. It's very surprising, and we believe that this should translate into properties of CN provable through its category of models. We haven't thought exactly, we haven't thought exactly about what you said, but we are hoping to achieve something by using that, the category of Boolean algebras, it's very nicely behaved. As you said, it's a variety. So we should explore these properties.
Exactly.
Okay, we have non-trivial Boolean algebras, but then it's a quasi-variety. You just need to add an inequality. So it's still very nice, and we believe it should turn out some strong results about the Costas hierarchy. Yes. Good
Very
to know that we thought about the same thing. It's always good to know.
good, good. I think that I'm done. So I haven't some other suggestion, but I will send you.
Yeah, if there are minor suggestions that you want to send by PDF, we would be very thankful. But as we said, if some other important question turns up before the end of before we all disconnect, you can ask again. I think there's absolutely no problem at all.
Okay.
So
No, it's good.
thank you for the comment.
It's perfect. Thank you. Thanks so much.
Thank you very much, Darlan, for such very interesting and nice suggestions and comments. It was very valuable for us. Thank you very much. For everybody at this point has made very interesting comments for us. Okay, thank you very much for your participation, Darlan. Then it's a pleasure to invite my dear colleague, Walter Carnielli from the University of Campinas. Thank you very much, Walter, for being available to read such a long text. But you are you know about this stuff. You have hearing several talks by Guilherme in our internal seminars. Well, we would like to hear your comments about the thesis.
Okay, thank you very much. Thank you, all the colleagues, for the nice comments. I had written some 2 or 3 pages with questions, but now half of them are deleted because of I took into consideration the nice questions and replies by Yana, by Darlan, and by Hitoshi. So I am a privileged person because I have this little monster in my hands, right? So he gave me in paper because I was having some difficulties for reading. Yeah. So in the beginning, I was very scared to read that, but then I took courage and started reading page by page and making annotations, and I give you, Guilherme, personally all my comments concerning little points there. Yeah, it's easy for you to do. So let me start with some very small considerations. So I have some linguistic corrections in the introduction and in the final consideration, because I think it's very important for you to have a nice and beautiful piece of work that's going to be in the library, in digital library forever, right? So I make some annotations. Now, a very important point is that you have to be careful with the word tableau. Everyone makes a mistake. So tableau is X, is a plural form. Right? So there is tableau and tableaus. Tableau is X in the end.
Yes.
And they are completely different things. One is singular and can be used as an adjective, and with X at the end is a plural and cannot be used as an adjective.
Oh.
So I made all the observations.
Okay.
It's very important because, again, this will be in the library forever, right?
Yeah, but we plan to put in archive as well, so it should be very nice.
So I have made all the possible annotations with every place I find tableau, and that's okay. So now, concerning some more important questions. So I think it's very nice. In the beginning, I did not like the connections among chapters. I said, as Darlan says, it seemed to me there was 2 different parts, and they did not connect very well. But then I was able to see the connections. And one of my questions is the following: one important question, important result that you have is this one here. CDF generated are equivalent to absolutely free multi-algebra. So this is a very important result. Okay? This is a nice resulting in universal algebra. But my question for you is the following: did you try to find some other like Birkhoff like results concerning universal algebras? For instance, I mean, you have something nice in universal algebra, but not exactly in the direction of Birkhoff, right? Would it be possible to find some characterizations in the kind of sub-reducible structures and so on?
Look, Walter, this is one of the most desirable results we would like to achieve. Okay, that's why we attempted. We would like a nice characterization of whatever varieties of multi-algebras are. We don't even know what should a variety of multi-algebras be. So there's the first problem. So we decided to start from the beginning. We started with absolutely free algebras. This seemed to have a nice generalization. The weakly free multi-algebras, we define it. And okay, our generalization seems to us to be the correct one. Because if you generalize algebras of formulas and you generalize unique extension of homomorphisms, you end up with the same structures. So to us, this suggests that, okay, we have the correct generalization, or at least one correct generalization.
Mm-hmm.
Now, what would be the next step, in our opinion, to find relatively free the generalization of relatively free algebras? That starts to involve identities of multi-algebras, which is a very difficult point to study. Darlan has brought up the difference between logicians and mathematicians regarding identities. One group thinks about full multi-homomorphisms or even other notions of identities. Logicians think more about legal valuations. So it's very difficult to think about identities and so to define varieties. I'm sure you know about that.
Mm-hmm.
I'm just trying to show how we thought about the problem. So we started with absolutely free algebras, and now we are thinking a lot about relatively free algebras. That is, algebras of formulas, quotient something, some idea of identities.
Mm-hmm.
This is very difficult, and we are trying. At least I am trying. My blackboard here at home is covered in diagrams and odd structures I found to give counterexamples. It's a big mess. We are trying to take very simple signatures, such as with one negation that is involutive or something like that. Try to get a relatively free multi-algebra in that signature and try to look at the properties of this structure, how it connects to weakly free multi-algebras. So yes, Walter, we would love to find Birkhoff theorems in this context, but they seem very difficult. Darlan, Hugo, Peter, they thought about it a lot from the point of view of mathematicians, and I think they agree with me that, okay, there's no easy answer. There's no answer at all, apparently, so far. And we are trying to look at this from a more logical point of view. Not logical that they are not logical, but more from a point of view of logicians. And we have one result that are weakly free multi-algebras. We found a few applications, but we are still working on it. So,
yeah, of course, yeah, thank you. I don't, the thesis is already great and complete, in my opinion. I am not asking this for you to add into this thesis here, but for the future, right?
yes.
This is
future
a
work.
work for the future. Okay, thank you. Another question I have.
Walter, if you allow me, I would like to add a comment for your question. It's very interesting.
Yeah.
And it's another question we have think about for a long time, since the time I have supervised the thesis by Ana Claudia Golcio. One of the our main interest was try to define, to obtain a kind of Birkhoff theorem for multi-algebras, or at least for this kind of semantical structures for certain logics. And it's very difficult question, and we have looked in the literature on multi-algebras, and the problem is how to interpret an equation in a non-deterministic environment. This is the main question. There are several attempts in the literature, but they don't arrive to satisfactory results. Apparently, this is not the way, or then there is a very strange and non-standard interpretation of equation that can give a solution. But we learn a lot with Javier Caicedo, the distinguished Colombian logician and mathematician. The first important paper published by him was a generalization of Birkhoff theorem for Tarskian structures, that is, algebraic and relational structures. And the main idea of that approach by Caicedo was not trying to generalize the proof of Birkhoff theorem, the traditional proof, but the result itself, going by other ways. If you insist in generalize one proof, a specific proof that use techniques which are permeated by the formalism itself, then in algebraic universal algebra, you have some techniques and concepts, etc., that works in this specific framework. If you change the framework, going to a more general framework in which you have relations instead of functions, strictly functions, then that technique, the traditional techniques, doesn't work. Do not work, that techniques. Then you need to think about the absolutely different proof. That's the point. Then if you try to obtain a generalization of, well, the variety is characterized by equations, maybe it doesn't work in the non-deterministic framework. Maybe you need another thing. The same case with block and Pigozzi. The same case with block and Pigozzi. The Leibniz operator leads with congruence. Congruence in non-deterministic semantics has no meaning, or there are no relevant, apparently, because you use the main feature of a non-deterministic semantics is that you don't have congruences. The connectives are not true functional. That's exactly the point. Then the Leibniz operator is irrelevant. Or then you need to define a very general, revolutionary notion of a Leibniz operator.
Yeah.
Is that revolutionary notion of equation? Right?
Just Darlan would like to make a comment. Sorry, while we are still on the topic.
Okay, it's just because I think that I thought now is the isomorphism between multi-algebras and the algebras with an relation symbol could answer something about that, because with this category, algebra with a relational symbol could give you an difficult to express the multi-algebra with equations, because we have a relational symbol, but could be a good structure in point of view of model theory. It's not a variety or quasi-variety, but it's I forgot now, but with axiomatized with a very good theory on point of view first order logic, a good theory. With we don't have the same properties of a Birkhoff, like translate equations with operators on the algebra, but we have something more less strong, no?
Yes, that's something to think about. This equivalence suggests a lot of things, but we should expect these ordered algebras to be at least as difficult to work with as multi-algebras are. I don't know. I think they should be difficult to work with, because multi-algebras are, the objects are equivalent. So, but that's very important to keep in mind, that we can always go back to this equivalence to look at things.
Yes, I remember Horn structures. I believe
Horn structures, yes.
Exactly. Horn structures here, I believe so.
Okay, thank you. Let me pass to another more logically related question, right? You said that you prefer to work with bi-evaluations or b-evaluation. You said it. You call them bi-evaluations, right? That's okay. Prefer to work with bi-evaluations than to other things. And that reminds me of the work of the Schusko. So bi-evaluations, in your sense, are very, very universal. So in a sense, that was discovered by Schusko, right? And I wonder why not to mention Schusko in this aspect, because bi-evaluations are so universal because of that.
Yeah, we failed to mention, but our result that proves that every Tarskian logic is characterized by a two-valued area matrix is Schusko's result.
That's a Schusko result.
Yeah, I failed to mention that. Yes, that is bad.
That's
the result on my own, but we should mention the relevant literature in this case. Yes, I would add.
You still have 1 month to make corrections, small correction to the thesis, right?
Yes, I have some time.
Exactly.
I have
so
I don't know if it's 1 month or even more, but I will make very many small corrections, and this won't be one of them.
Talking about the little points that have been forgotten, let me remind you about one thing. Did Da Costa really refer to inconsistent sentences as opposed to well-behaved? So in my mind, in my reminds of Da Costa writing, he never talks about inconsistent sentences, as you say, right? It only talks about well-behaved. So that's a very small historical point. But perhaps you should pay attention to this.
Okay.
Maybe he did. I don't know. I never found in his writings.
I couldn't say exactly, but it seems to me that you are right, Walter. It should be well-behavior, not consistency.
Yeah.
Yes.
Now, another small historical point.
Walter and Guilherme, this is Itala. I think that I have never found inconsistent sentences in Da Costa's work.
Okay.
He spoke about inconsistent logic, inconsistent theory, but not inconsistent formula or
sentence. Yeah, you're right.
This was introduced in your papers.
Yes. When Da Costa introduced her system, he speak about inconsistent systems, because the word paraconsistent was not yet invented. But then he talked about inconsistent formal systems, but never about consistent sentence. You're right. Yes.
Okay.
Thank you for that thought, Walter.
Yeah. Another small point. I see in your work in many places the seeds of the idea of a possible translation semantics. Right? But you again, you never mentioned that. So perhaps you could at least see critically, oh, this is okay, it's different from this point, but blah, blah, blah. Just to make the thing complete from the history of ideas.
Okay, I can mention them explicitly, but you are correct, because in my qualifying exam, you suggested that I should look between the connection between array matrices and translation semantics. I always kept that in mind, but I never found the time to really delve into the subject. So, okay, I will make it a little more explicitly, but as you said, I don't have the time to add the chapter I would like, comparing possible translation semantics and array matrices. That will be for future work as well.
Yeah, of course. I don't have in mind adding a new chapter. Please, it's already normal. So what I had in mind is only you making some critical points, like a couple of sentences or so.
Okay.
Right? But don't worry, I'll give you by writing all these suggestions here. Okay.
Thank you.
Walter, as you can remember, we together write a chapter for First Rift for Gabay, speaking logic, and we found a first, let's say, connection between possible translation semantics and N matrices.
Exactly.
As you can remember, we showed that you can reproduce, let us say, N matrix semantics by means of a suitable possible translation semantics. Then I'm almost sure that it is possible to extend that result to restricted N matrices. Possible.
Oh yeah, absolutely sure. It's just restricting translations.
Exactly. Imposing more restrictions to the translation.
Yeah.
Yes. I thank you for
making a filter on the translations.
Yes, exactly.
That's all. Okay. Fine. I have another more questions, and my last question will be more important, I think, and philosophically at least, right? Under which? By the way, incompatibility is a great idea, even if Brandon and Jaroslav Peregrine have already worked on that. You did it in a completely new way, where I find the sort of a filet mignon, the beef of your thesis, right? Everything is fine, but the idea of incompatibility is great. It's really good. So now a couple of little questions concerning compatibility. Under which conditions are incompatible statements or incompatibility reduced to inconsistence, right? So inconsistency should be a kind of special case of incompatibility. But do you work specifically on making clear under which conditions incompatibility turns out to be inconsistency?
Well, let me start by saying that thank you for the comment on our incompatible logics of incompatibility. I still think that array matrices are more interesting, but the logics of incompatibility are indeed one of the main points of the thesis. And I agree. I think that the problem in Brandon and Peregrine's work, they attempt to achieve everything at once. Yeah. We chose a smaller problem and I think we got nicer results because of that, because we chose to specify a few conditions while they try to tackle the whole problem at once. So under which conditions incompatibility reduced to inconsistency? Well, I think in a few systems of incompatibility, we consider by trying to, by adding an axiom under which incompatible formulas are necessarily, no. Now that I think about it, I think we haven't considered this reduction in very depth. I think we don't have a lot to say about that, actually. Sorry. In the more general incompatibility logics, without negation, I think there's a priori no connection between incompatibility and negation. They are completely unrelated systems. In the most simple logic with incompatibility and a paraconsistent negation, that happens as well in the NBI, because we have a tertium non datur on one hand, and we have incompatibility at other. They coexist, but they don't talk with each other. The other logics of incompatibility we consider, they add some interplay between the two notions, but I wouldn't say they tackle the problem of when incompatibility reduces to inconsistency. I think it is a problem taken even further, or connection between inconsistency and incompatibility. So we don't have any results on that, but it would be, we would start by taking NBI CIW, NBI CI, and adding axioms and studying them furthermore. But so far, sorry, Valdo.
No, that's okay. But you can leave it for, like in the last paragraph, as questions for the future.
See, yes.
Questions to be worked out.
Yes.
You don't have to add a new material, but just paying attention to things
No,
you should.
Valdo, the thesis won't grow any further. I can't let that happen. It's already too much. I will add a few comments, a few corrections, but no new chapters, no new sections, only comments now.
Yeah, okay. Now, my final, I give you everything by writing, but I have a final question, which is, I think, very important from the conceptual point of view, and that never came to your mind, I suppose. It has to do with probability theory, right? So in probability theory, people talk about statistical independence or statistically independent occurrences if one does not affect the probability of the other. That's a very important concept in probability theory, right? It's so important that it is something has to do with the roots of philosophy of science. Like, for instance, if I am judging the probability of alpha and beta, it's only the product of probabilities if I can prove, or if I know that the alpha and beta are incompatible or independent. Otherwise, I don't know what to do with the probability of two events if they are not independent, because I don't know the connections among them or between them, right? So this idea of incompatibility and independence is very important in probability and statistics. And these statisticians don't know what to do with that. They give several different definitions, etc. Comes another guy and gives another definition, and it's a mess. And I think what you are doing could be connected to the idea of incompatibility or independence in statistical and probability. Again, it's something for the future, because it's not easy to do. but why not to make a reference to this problem, right? I think it's
I
very,
can-
very much important.
I can make a comment about it in the thesis, and I have thought about this, that
Ah,
a model of incompatibility would be independence in statistics.
yes, yeah.
But I know very little about logics dealing with probability, so my comment would be very shallow, but I think it's an important connection with the literature, is an important model for incompatibility, talking about independence in statistics. But I would very much like to study this in the future. But I have to say, we will have to study a lot about logics of dealing with probability, and there's a long way, so I can say something more relevant about it. But I have thought about it.
Good.
I think maybe even because you made some comments about logics of probability in my exam. I can't recall right now. I have the recording. I can check it later. But I have certainly thought about the asymmetry between incompatibility and independence. It certainly seems relevant to mention it in the thesis.
Yeah, because some statisticians define it in terms of logic purely, and you are doing some generalization of logic. So they will be interesting for them.
That seems. I would be very happy if logics of incompatibility could play a role in studying logics of probability. That would be an amazing application of this system.
Yeah.
Yes.
Oh, the best application of all. The best of all, because it's used everywhere.
Right? Yeah.
Very nice suggestion, Walter. Thank you very much. Very nice suggestion. Very interesting.
Thank you. Okay, so I finish here my comments, my arguments for you, and I'm okay. Now we can, Marcelo, I think you pass to the other room.
Yes,
right?
yes. Previous to this, we have here the presence of the alternate members of the jury, Hercules Feitosa and Italo Ottaviano.
Sorry, let me just interrupt you for a second.
Of course.
I noticed some time ago, I don't even know if he's still watching, but Martin thanked us for the presentation and all the comments in the chat. People that are only watching the presentation can make questions and comments to the chat. I'd just like to mention, if there are any questions, any comments, people watching, I don't
Guilherme, could I, is it possible for me to say something? Because
of course, you are invited.
Only a few words, because I would like to welcome Anna, Hitoshi, Darlan, Hercules, and Walter, but I would like to congratulate Guilherme and Marcelo. I have followed Guilherme's work during several months, and during these last years, I have participated in several seminars where Guilherme has presented his work. And so I like your work very, very much. As at Hitoshi, the system, the work is very, very beautiful. It's instigating, motivating, and you have a lot of things to continue obtaining and working. As I am an alternate member of the jury, I'm not supposed to ask you, but I repeat, I would like to congratulate you and Marcelo, your colleague, for the work. And I apologize because I was supposed to be participating in a seminar since 10 o'clock. And so I leave the room.
Okay.
And thank you for inviting me to participate, even as an alternate member of the jury. And
Thank you very much.
congratulations to all of you.
Thank you very much.
It was very
Thank
nice.
you very much for your participation. And if you had the time, I'm sure Marcelo would invite you to ask questions, make comments. If you have to go, okay. But Marcelo, you were about to ask the alternate members of the jury if they had comments or
Yes, of
questions.
course.
Yes.
Probably
Yeah.
Hercules has questions.
Okay.
It was very nice to meet Hitoshi and Anna and Darlan here, even online. This is for you. And I hope we can meet personally soon.
Thank you,
very
Itala.
much.
Bye.
Thank
See you
you.
next time.
I have to go to the end of the other seminar. Bye.
Okay. Bye-bye.
Bye-bye.
Bye.
Okay. Well, Hercules, thank you very much for coming here and for being part of this jury as an alternate member. And once again, you are kindly invited if you want to make some comments or remarks about the thesis. Your microphone is turned off.
Okay, now it's on.
It's muted. Yeah.
No, now it's muted again.
Okay.
I think now it's on.
Thank you for the invitation. It's a pleasure to be with you. It's a pleasure to know today Anna and Hitoshi too. I don't have exactly questions, but I will do some observations or comments. You have worked hard. It's a very strong work, and I see at least three main topics in the thesis, and you comment these three, maybe four particular subjects important that you have developed. And the first one is a theory of multi-algebras. And in general, you have been paraconsistent minded in all the world. I think one thing you can develop in next moment, if you be interested, it's try to develop these multi-algebras using other elements involving the empty set and other possibility to define the homomorphism. Few people in the world have worked in abstract algebra, and abstract multi-algebra, maybe only you and more 2 or 3 people. So it's a very important way to develop work and compare these results in the next moment. But in this moment, it's okay. A second.
I would just say that multi-algebras where you can achieve the empty set are sometimes called partial multi-algebras. To tell them apart from multi-algebras, there is some study is still ongoing on semantics based on partial multi-algebras. But we show that they are actually a special case of our restricted non-deterministic matrices. Now, you say there isn't a lot of study about partial multi-algebras. Yes, I think because some people try to relate them with relation structures and try to minimize their importance. I think, yes, it's very true that people don't pay the attention that partial multi-algebras deserve. They are not very popular right now, not as much as multi-algebras are, surely. And we believe, okay, this thesis talks about, as you said, talks about many things, and partial multi-algebra seem like a relevant topic of study as well. Sorry for interrupting.
A second subject that I see in the paper is the Rn matrices. And this new model generalizes several types of semantic models. I believe it would be interesting to convince the community that you have a generalization, because you have used in the final of your thesis the idea of translations. Translations, I believe, is used to compare logics, to pass property of one logic to another logic. And in general, it's difficult to translate logic from a group, for example, many-valued logic, in another group to model logic. Sometimes we have some type of translation, but in general, they are not schematic. They are difficult functions. And using a general model where you can put several logics, maybe it's possible to use translation and define easy translation between them, because you have just a type of model for all the logics. Epstein, in that book about propositional logics and translations, have used the semantic of set attributions, because it's just a type of semantic for all the logics involved. And I believe it's interesting to convince the community that you have a very general semantic for new and difficult logics. It's okay. Huh? And the third way or third subject I see is the logic of formal incompatibility. And my observation is exactly the same of Walter. I believe you can think about this group of logics without thinking about exactly as a type of paraconsistent logic. Put off the axioms of paraconsistent logic, use just the positive logic and the conditions about incompatibility, and try to think maybe you can get other type of logic, relevant logics, or maybe go in another direction. Yeah? So these are my observation, my comments, and just one particular comment. When you have developed translations, you have said that conservative translations were proposed in the paper of 1999 by Jaro da Silva, Itala, and Seth, but there's nothing about conservative translation of that paper. Conservative translations appeared in other people, in other papers.
Oh, sorry about that. Misconception of my part.
Thank you for pointing out.
An historical important point. Well,
maybe Hercules, if you can send us the right or the best references, we will be grateful.
Maybe a paper de 2001 in the conservative translations, the name of the paper, I believe there was introduced in the community in a paper published.
By him, by himself, by Hercules.
Yes, by me and Itala.
Yes.
Thank you.
So you mentioned the second and third subjects you pointed out. First, Aryan matrices. Yes, we tried to show that they indeed generalized other semantics, such as kern semantics without possible words and PN matrices. But you are correct. We haven't proved that they generalized non-trivially. That is, PN matrices are a special case of Aryan matrices. But are Aryan matrices a special case of PN matrices? In other words, are the two notions equivalent? We don't know that yet, and that's something we very much like to study in future work, that is precisely compare different semantics. And for that, translating systems, difficult systems to characterize, they seem very important in helping us to explicitly tell where one semantics expressiveness ends and other starts. That is an important topic of future work for us. Regarding your third topic, yes, I will try to add to the thesis, as you and Walter suggested, a few comments on, okay, logics of incompatibility, their only application is not only logics of formal inconsistency. We can think on them on terms of probability. Maybe they have applications in relevant logics. Itoshi suggested us a system with that axiom by Brandon. We could point out that there are strong philosophical applications of incompatibility that do not relate at all to inconsistency, that both okay, we thought about incompatibility by looking about inconsistency, but that does not mean that we should only look at incompatibility through the lenses of inconsistency. There are other points of view we should consider. And okay, the thesis cannot fit more logics, more systems, but we should make comments about that because that is important. Maybe in the future, people working with logics of probability or relevant logics can look back at this and when logics of incompatibility first appeared, at least as we formally define them, and maybe they can become a part of the study of logics of probability and so on. So thank you for the comments, Hercules.
Thank you very much, Hercules. Thank you very much. Well, now I don't know if anybody has additional question or remarks. Then we can go into the second part of this ceremony. Then all the members of the jury, we can invite Hercules.
I'm free because I'm not exactly a member of the jury in this moment.
No, but you can participate with voice okay. Without voting. Then we will leave temporarily this room. Okay, and we are entering into the Google Meet link. I sent to you. Everybody has that link.
Mm-hmm.
Then
do we disconnected from this one, Marcelo, or we disconnected?
We disconnect and then we enter again. Okay.
Okay. Disconnect and connect again.
Okay. Not to abuse of your internet. Two simultaneous meetings may be too much. I don't know.
Yes, exactly. Yes. Well, we will leave out temporarily and we will enter into Google Meet. Okay.
Okay. See you now. I'm leaving now.
Okay.
I'm leaving.
Everybody's here. Okay. All the members of the jury are here together with the candidate.
Hercules is not here. Okay.
Here.
He has arrived.
Okay. Perfect. Okay. Well, Guilherme, after deliberation of the member of the jury, by unanimity, we decide that you are approved for your PhD. Is approved, then you formally has the title of PhD in philosophy. Congratulations.
I really okay.
Of course, we have the compromise to make all the changes, the minor changes that were suggested. Okay, all the minor changes might be implemented. We have time, technically 2 months, but our institute requires 40 days. Then we will try to make the changes in at most 40 days. Okay.
Okay.
Well, you're approved.
Thank you very much for attending, for going through my thesis. I'm sorry. I know it was long, but it was all topics we have researched through my PhD. And thank you very much again. Thank you all for the suggestions, the comments, the questions. There's a lot of new, as I suspected, there's a lot of new ideas to consider. I had to keep up a log of all ideas of future work. And of course, I will make the suggested modifications in the thesis. As I mentioned, and everyone agreed, I can't write a new chapter, but I will make comments where comments are needed. I will make small corrections, mainly historical corrections. I found that interesting, but I committed more than one historical error. But in less than 40 days, everything will be ready.
I'm sure.
Okay, thank you.
Yes.
May I call you Herr Dr. Toledo?
Somehow you're doing the German way, Walter.
Yes. No. I always joke that I will not ask of anyone to call me doctor. That's not necessary. I just want to be a doctor. That I'm very comfortable.
I would like to say that it was a pleasure to work all these years with Guilherme. Was an excellent student, one of the best students I had. He's very responsible. He's very good. He's a very good mathematician, very good logician, and he's learning to be a good philosopher also.
Thank you.
Guilherme, congratulations. We were all very impressed by your passion to what you do, and I hope you continue with it, because it will bring more great results to the field. So I encourage you to keep your passion.
Yes.
Also, Guilherme.
I think just I dedicate myself so much to the thesis, and I believe I will continue. I will attempt to continue doing so. If I can put a fraction of the dedication that I placed in this thesis, I think everything is going to be all right.
Well, I would like once again to thank emphatically to the members of the jury. I'm very grateful, Guilherme and me. We are very grateful for counting with you. You are very important colleagues in the area covered by the thesis. Anna, Hitoshi, Dalan, Walter, Hercules, all of them are very excellent colleagues.
We couldn't hope
distinguished
for a more
colleagues.
qualified jury for my thesis. Yeah.
Good.
Exactly, and unfortunately, Hugo cannot attend, but
Yeah.
her presence, his presence will be very important also for us. But we have Dalan here that is very important.
Representative of
Representative
that
group.
school. Yeah.
And then when, thank
thank
you.
So, Guilherme, congratulations. It's
Thanks.
really hard work, and it was wonderful to read, and very
Thanks,
good
thank
work.
you very much.
And I hope to meet you in the future to work about the
Exactly. There's a lot to do.
Maybe when they open a position in Bahia, Guilherme, you could apply to it.
Yes.
The future is
Oh,
One of the best groups in
Carlos'
logic.
work, Samuel work, incredible. Bahia is amazing in logic.
And you will live near of the beach, and so it's
Exactly.
Great. It's a great place to work. Great place. Great place.
Dalan is
By the
from
way,
Salvador, right?
By the way, we all are going to be there by the Brazilian Logic meeting, right?
Exactly.
In September.
Of course, in September.
September.
Hitoshi and Anna, you're invited to participate. It will be a pleasure to receive you. In September in Salvador, Bahia, paradisiac place. Very nice place.
Thank you.
Yeah,
and congratulations from me, Guilherme. Just two things. One, it was great that you had a lot of surprising results, and also, more importantly, perhaps, that you have so many questions to address after finishing. Right? That's extremely important, and I think it just showed how you're promising. Right? So just keep running. And the second thing, I really admire how you smile. This is great. It makes people very happy. And I really hope that even during the hard time of this research, you don't forget how to smile. I think it's really great.
Thank you very much.
It's very sweet. And I really hope that you would keep up with the good surprises. I'm really looking forward to more and more from you, Marcelo, and your colleagues.
Thank you very much. Again, to all, thank you very much. It was incredible, all of this.
Yes, very nice.
But Guilherme is incredible. He smiles even when he's being criticized.
But there was no really criticizing here.
But I mean, in other occasions, I have seen you smiling when being criticized.
Yes.
Okay, it's important to look at the bright side of things. Yes.
Good.
It's the only way to look at things.
Exactly. Well, I think that we are finished. More than 4 hours. Thank you very much, Anna, for your contribution, for your participation, for the
It was a great
reading.
pleasure.
It was really a pleasure to come with you. Hitoshi, same thing. I'm very proud of counting with you. I'm really proud of counting with you. You are young but great names in the area.
Pleasure's mine, Marcelo, obviously. Thanks a lot for thinking of me even.
It was very nice. Dalan, I think, muito obrigado por estar aquí. Thank you very, very much for reading,
so much for
make these suggestions. Well, dear Walter, as usual, contributing with very smart and intelligent comments and deep comments and observations. Thank you very much for the support along the years, because you have participated with Guilherme in our internal seminar. It was very nice. Hercules, thank you very much for your comments and for accepting participate as an alternate member. It was very nice to have you here. And well, Guilherme, Congratulations, parabéns.
Thank you. Professors Hitoshi, Ana, Walter, Darlan, Hércules, Marcelo, special thanks to you for all these wonderful years. Thanks to Itala, she's not here, but I found it important to. Thanks Hugo also, he could not be here. Thanks him a lot. And this was very special. Thank you very much. I'm very happy. Doctor, finally. Took some time, took some working, but finally. And yes, many questions, a lot of work to do. That's very inspiring. Okay.
Last but not least, I would like to take a picture of this meeting. Okay. I will take a picture now.
No earphones.
Okay. Now 1, 2, 3. Yes. Okay. Let's see. Just a second. I will see.
Good.
Very nice picture. Very nice picture. I will send to you. I will.
Let me say.
Yes.
Let me say my final words. Anna, just one more thing. For you with a very silly question, if you don't mind. Can you hear me?
Yes, I hear.
I mean, if you allow me, I'll be writing an email to you with a very silly question. The silly question is the following. When I was in Moscow, I bought something in a market, which I don't know what it is.
Oh,
it's written in Russian handwriting.
Oh, okay. Send it.
I don't know what it is. It seems to be a pepper, or I don't know. So I could not translate it.
Don't use it before you check.
Okay, so I'll make a picture and send to your email.
Yes,
Okay.
you have my WhatsApp number. Just send it to me before you do anything stupid.
Yeah. It's not only, I have 4 or 5 different kinds of powders, all of them red and green and completely different. I don't know what they are.
Okay.
Yeah. So thank you. Spasiba, arigato, obrigado a todos. Okay. See you next time.
Thank you very much to everybody.
Thank you all.
And I hope to see you in the near future. Okay, I hope to see you, all of you.
Yes.
Okay, thank you very much once again.
Bye-bye.
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 Bye, Hercules. Bye-bye.
Bye.